I'm going to go ahead and draw the parent function. These are the things that we want to try to remember. Again, as we move forward in math, sometimes math becomes about how well you recall the information and if you don't. I've been told that students don't like when teachers say that. I don't know what else to say. Some people remember it better than others. The more we can work to remember it, the better off we are. Sometimes you actually have to go back and review some of the things we've covered before. But that's the parent function. It's called the reciprocal function. So what is the transformation that happens here? Left 2, very good. So the plus 2 is on the inside, so we move it left 2. The next one, do you remember what happens if there's a squared? How does that look different? If you square something, it makes it positive. So therefore, the graph will be above the x-axis. So I will draw the parent function in green so you can all see it. And then we're going to look at the transformation. What does the minus 3 do? Moves it to the right 3. And then the negative on top, the 2 won't do anything, but the negative will create a vertical flip. So I'm going to move it right 3 units. And then I'm going to flip it vertically. And so that's the shape. Just going to do a couple more here. What is the transformation going to be in this one? Up 3. So I'm going to, again, draw my asymptote. And I'm going to go up 3 units. And I draw it as such. See if you can do the ones I starred on your own. Check with the person next to you, see how you did. Try those 2 on your own. Go ahead. Did I do it correct? Any questions? We all agree that's a review lesson from what we've seen before. So let's look at the application of this unit and decide what makes this slightly different. It says consider the characteristics of this rational function here. Y is equal to x squared minus 4x over x plus 2. That's a rational function. And it actually can turn into y equals 12 over x plus 2 plus x minus 6. And I'm going to show you how that happens. And it's in this unit because we talk about dividing polynomials. So I'm going to take this and I'm going to divide it out. X plus 2 goes into, I have x squared minus 4x plus 0. What do you multiply x by to get negative, or to get x squared? X. So you place the x above the negative 4x because it is an x to the first power. We multiply it through and we get x squared plus 2x. And we subtract. What is negative 4x minus 2x. Negative 6x. We drop the plus 0 and we start again. What do you multiply x by to get negative 6x?
Negative 6.
So we put the negative 6. We multiply that back through and we get a negative 6x and we get a minus 12. We subtract, and 0 minus negative 12, positive 12. Therefore, we have a remainder of 12, so it's plus 12 over x plus 2. Can everybody see that these two are, in fact, the same? Okay? Now, that looks a little bit different than the type of rational function I've seen before, doesn't it? The fact is that this rational function has something interesting to it. And if you look at all of these others, you can tell that this one, for example, where is the denominator equal to 0 for an x value of? And therefore, you have a vertical asymptote at negative 2. This one has a denominator equal to 0 at 3, so it has a vertical asymptote at 3. This one, denominator is equal to 0, 0, vertical asymptote at 0. Notice that where the function is undefined is where something kind of funky happens to the graph. So if we go back to this guy, where is this one going to have a vertical asymptote? Negative 2. So a vertical asymptote is going to happen, or we're going to see what happens when you actually get a hole, where the denominator equals 0. That's part of it. The second part is this guy right here. This is called our quotient. Don't focus on the 12 or the x plus 2, but focus on this guy right here. That's what we call our end behavior, or our horizontal asymptote. Show you the example of what we've already done. I want you to connect what we've done with that, okay? Look at this guy right here. See how plus 2 is on the end? That was the quotient if we were to divide something. So look at your horizontal asymptote. It has a height of 2. This one right here, a plus 1 on the end. So your horizontal asymptote is at positive 1. Everybody see that the thing on the end tells you that shape? So if we were to look at this, notice we have an x minus 6. So instead of a horizontal asymptote, you would actually have a slant asymptote. It would have the shape of a line, okay? Out of the shape of a line. That thing on the end is what tells us that shape. And we'll get to that in a little bit. So this is just kind of the breakdown, and we're going to try some examples together. But that's the shape. And then the denominator equals 0 is where we get the vertical asymptote. How do we find x and y intercepts? Very simple, just like we always have. You take x and y, plug in 0 for x, you plug in 0 for y, and you solve. That tells us x and y intercepts, and that should be able to give us a really good idea of what the graph looks like. Ideally, I wanted 2 days to do this lesson, just because we need to test on Friday. We've only got one, so I'll be reducing a couple of the problems from your assignment to focus on what's really important. But here's a question that you can expect to get on the test. It says, please provide a graph of the following rational function. Determine its intercepts, its asymptotes, its end behavior if it's different than the asymptote, and the location of a hole if it exists. The hole that we're going to look at is on the next page. It's not right now, but I want to list these important information. X-intercept, Y-intercept, vertical asymptote, and horizontal asymptote. Okay? The first thing I'm going to do is I'm going to divide this function out. So I'm going to take x minus 1, and I'm going to divide it into negative x plus 4. What do you multiply x by to get negative x? So I put the negative 1 here, and I multiply it back through. Negative x plus 1, and I subtract, and I get 3. What do I put on the end here then if the remainder is 3?
Plus 3 over x.
3 over x minus 1. Now that it's in that form, I just want you to understand that that is the same as 3 over x minus 1 minus 1. That those two expressions are the same, are they not? We are more familiar with this one right here from what we've graphed before. So we're going to look at that. What do you think the vertical asymptote is going to be? Why? Because that's what makes 0 in the denominator. Whoa, sorry about that. The quotient, the thing that you divided that you came out with, that's my horizontal asymptote. If you notice, this thing is shifted down 1 unit. So therefore, the horizontal asymptote is y is equal to negative 1. Very good with that? And then finally, we want to determine the x and y intercepts. It's not too difficult to do so. In order to determine the y-intercept, I'm going to plug in 0 for x and see what I get for y. If I plug in 0 for x, what do you get in the top? 4. Very good. What do you get in the bottom? Negative 1. And 4 divided by negative 1 is? Negative 4. So negative 4 is my y-intercept. Here's where sometimes people get confused is with the x-intercept. To find the x-intercept, I plug in 0 for what? I plug in 0 for y. Now watch when I plug in 0 for y. 0 equals 4 minus x over x minus 1. Let's think about that. When is a fraction equal to 0? Is it when the top is 0 or when the bottom is 0? If I have 5 over 0, that is undefined. 0 on the denominator does not give us an output. But if you have 0 over 5, that's equal to 0. Does everybody see by that logic, we want to know when the top is 0? What number would give you 0 on the top? 4. So therefore, the x-intercept is 4. So if you want to figure out the x-intercept, just set the top equal to 0, and that's where it is. So I know that this function crosses the x-axis at positive 1, 2, 3, 4. And I know it crosses the y-axis at negative 1, 2, 3, 4. And I have my shape. Okay, for number 2, we got the x-intercept, we've got the y-intercept, we got the vertical asymptote, and we got the horizontal asymptote. This one's a little bit different because there's no x value in the top. So there's nothing to divide x plus 2 into. You see what I'm saying? Like, watch as I were to write it out. X plus 2 divides into 0 x minus 3. What do you multiply x by to get 0x? You multiply it by 0. So everybody see that you're not, if you divide it, you're just going to get the original function that we have there. So this is already reduced to its simplest form. Dividing won't help us because there's no x value up there. what is going to be my vertical asymptote?
-2.
-2, that's where the denominator is equal to 0. X equals -2. You can see that in this situation, I had a -1 on the end. I don't have anything on the end there. So what's going to be the horizontal asymptote? 0. The y-intercept happens when you plug in 0 for x. If we plug in 0 for x, we get 0 plus 2 is 2, so I get a -3/2. And for the x-intercept, that happens when y is equal to 0. So I want you to think about this. If y is equal to 0, are we looking for where the top is equal to 0 or the bottom? The top. Is -3 ever equal to 0? No. So does this ever cross the x-axis? No, it does not. And that will make sense by our graph. Let's sketch the graph. We said the vertical asymptote is -2, so we go back 2 units. The horizontal asymptote is y equals 0, or in other words, the x-axis. It goes through the y-intercept at -3/2. What is -3/2 approximately as a decimal? Yeah, -1.5, so it's going to go through right there. Okay. So we know that this one goes like this. And because it's odd, it's a x plus 2 to the first power, we know they're in opposite quadrants. It's going to go like that. Does it make sense looking at your graph that it does not have an x-intercept? Okay, doesn't have an x-intercept. So these should all kind of confirm each other. We're going to do one more, and then we're going to flip to 2 on the back side. What I would like you to do first for number 3, go ahead and see if on your own or with a partner, if you could take x plus 1 and divide it into 3x plus 0 correctly. Try to divide that one out on your own. Everybody okay with that? -3 over x plus 1 plus 3. Okay, now that you have that, go ahead, identify the vertical asymptote and the horizontal asymptotes. Write those two down. Okay, the vertical asymptote should be x equals -1. Anybody wondering how I got -1? The horizontal asymptote is y is equal to +3, as you can see the +3. What I'd like you to finish off with is see if you can figure out what the x-intercept and y-intercepts are by plugging in 0 in the appropriate spots, and then see if you can sketch a little bit of a graph. I'll show you guys a picture of Hayden's buck that he shot. Apparently Drescher shot too. What are you gonna do with all that venison?
We already quartered it, so we split it up in the 8-pound buckets and we take it to the mix.
Should make some jerky.
That's what we normally do, that or just ground venison.
How do you flavor that jerky?
Like a Cajun.
Cajun. I like me some teriyaki.
Yeah.
All right, if you plug in 0 for x, you get 0 over 1, which is 0. That means it goes through the origin. And if it goes through the origin, then the x-intercept is going to be 0 as well. Notice if you say 0 is equal to 3x over x plus 1, we set the top equal to 0, and you get 0 as well. 0 is the x and y intercept. Your graph should look like this. Horizontal asymptote at y equals 1, 2, 3. Vertical asymptote at x equals -1. It goes through the origin right here. And so it's going to sit up here as well. We good? Take out your calculator. What's that? So, a couple things that we can see here, Gilly, is number one, because it goes through the origin, it's got to be in the bottom, right? It can't be in the top. Agreed? So, and then because it's x plus 1, it's not squared, you know that they're in opposite quadrants, so it's going to have to be up here. You see that this piece right here, this -3 over x plus 1, that means that it flipped. Better?
Yeah.
Okay, good question. All right, so we're going to use our calculator on this next one, and we're going to start by dividing it. We're only going to do, I think, 2 examples left. We're going to take x minus 2 and divide it into 3x minus 6. What do you multiply x by to get 3x? So we drop that 3 right here, and then we multiply it back through. And when we multiply it back through, we get 3x minus 6. And we subtract those, you get 0. Uh-oh. That means something different happened. When it divides evenly, there's not a vertical asymptote. There's a hole. There's literally a hole in the graph. And we know where the hole occurs. It's pretty simple. The x value for where the hole occurs is at 2. Wherever the denominator equals 0, we have a hole then. When it divides evenly. We know what the graph pretty much looks like. The graph pretty much looks like 3. And if you graph y equals 3, it's just a horizontal line. Except when you get to 2, you draw a hole. So watch how I'm going to do this. I'm going to go up 1, 2, 3. And I'm going to draw this horizontal line. And when I get to an x value of 2, I put a hole there. I finish it across. So the coordinate for the hole is 2, 3. The horizontal asymptote is just y is equal to 3. Does this cross the y-axis? At 3. Does it cross the x-axis? No. So there's no x-intercept. I want you to take this and type that into your calculator, and we're going to see how we get exactly what we were looking for. Please make sure you put parentheses in the top and the bottom. Parentheses 3x minus 6 divided by parentheses x minus 2. And I'm going to choose to zoom as a decimal. I'm going to zoom number 4. When I do, I look at that graph. Give everybody a second to get caught up here. What do you notice about my graph?
Oh,
Yeah, there's literally a pixel missing off of the graph. That's not a mistake. That's exactly the way the graph looks, just like we drew it. Everybody see that? Let's go back to your notes. Let's try one more. I'm going to divide this one out. I'm going to show you an easier way to go throughout the division. Does anybody notice something interesting about this problem? Yeah, instead of dividing out using long division, I could see that these are factors. I'm going to just factor it out. X minus 2 times x plus 2 divided by x minus 2. What's going to happen? The x minus 2's reduce.
should be x plus 2.
What did I do? Oh, sorry about that. Thank you. X plus 2 on the bottom, those reduce. So I'm going to list my x-intercept, my y-intercept, my vertical asymptote, and my horizontal asymptote. Before I do any of that, I'm going to look at what the graph looks like. The graph wants to look like x minus 2. What does x minus 2 look like if we were to graph it? A line with a slope of? So y equals x minus 2. That's going to have a slope of 1 and a y-intercept of negative 2. So I'm going to draw that graph. The only difference is that when I get to an x value of negative 2, I don't have a vertical asymptote. I have a hole in the graph. So it looks exactly like what divided. It just has a hole in the graph. So I do not have a vertical asymptote. I have a hole. What is the x value for where that hole occurs?
-2.
Negative 2. To figure out the y value of where that hole occurs, we just plug in negative 2 into what it wants to look like. Negative 2 minus 2 is negative 4. That's where my hole is. This doesn't have a horizontal asymptote. It has what we call end behavior. This rational function wants to look like y equals x minus 2. As you look at the graph, does it cross the x-axis? It does, right here at positive 2. And it does cross the y-axis at negative 2. I'm going to take this and I'm going to plug it into my calculator. If you want to do it as well, you can. X squared minus 4 over x plus 2, parentheses x squared minus 4 divided by x plus 2. And if I zoom in this decimal view, we'll see if it gives me what I want. I just about ran out of room there, but you see I get that line, and then right when I get to the coordinate of -2, -4, I have a hole that exists in my graph, just like we predicted. So to summarize, we have rational functions in the form that we had before that we could graph, but we saw what happens when you need to divide them. When you divide them, we come up with these vertical asymptotes, these horizontal asymptotes, these shapes, and then if it divides evenly, you end up with a hole in the middle instead. And that's that. Go ahead and take out your homework. Let me see which problems I've assigned to you. Let's see which problems we actually want to do.
He does.
Yeah.
Where are we getting my own behavior from?
So the end behavior is always just whatever divides. So you can see that this divided off, this is what's left. That's what it wants to look like.
So whatever's left.
Whatever's left. Whatever's left when you divide it, that's what the graph wants to look like. Okay. Okay, all the problems 1, 2, 3, and 4, those 4 problems all work out like we did on the front. They all work out where you have a vertical asymptote, a horizontal asymptote, you have x-intercepts, you have y-intercepts. Okay, so you can follow our examples on those front page for that. If you flip to the second page, cross off number 6 altogether. And then for 5, 7, and 8, all of those have a hole in the graph. And I believe I have marked out the characteristics for you, whether or not it has a hole or end behavior or something of that sort. So those all divide evenly on the back. All right? So is there anybody else who does not have a study guide? Okay, test is on Friday. You have 2 days, Wednesday and Thursday, by which you can get some work done, ask some questions.